All right, today we're going on a pretty incredible journey. We're going to peel back the layers of our world to see what's really going on deep inside. That's right, we're heading to the center of the planet.
So let me just ask you, what's really under your feet right now? I mean, yeah, sure, there's dirt, rock, maybe some pipes, but what if we could just keep going? Down, down, miles and miles deep. What would we actually find?
Well, let me tell you, it's a world that is completely alien to ours. We're talking about a hidden world of just intense heat, crushing pressure, and these vast, slow-moving oceans of rock. This is literally the engine that drives our entire planet.
Now, I know that sounds super complex, right? But believe it or not, there's a really simple way to picture it. Just think of the Earth like an apple. You've got the super thin skin, then the thick, fleshy part inside, and of course, the core right in the middle. Well, our planet is built almost exactly the same way. So let's start our trip on familiar ground. We'll begin with that thin outer skin of the apple, which for us is the part we all call home. This is the crust. So here it is, the crust. And when I say it's thin, I mean it's by far the thinnest of all the Earth's layers. But you could argue it's the most important one, at least for us. Because it's where everything is. All the continents, all the oceans, all life as we know it. Our entire world is just resting right on top of everything else. But get this, not all crust is the same. There are actually two different kinds. On one hand, you've got the continental crust. This stuff is thicker and lighter, and it's what makes up, you guessed it, the continents. Then you have the oceanic crust. It's way thinner, but also a lot denser. And that difference in density? It's absolutely crucial. It's literally why the continents float higher than the ocean floors.
All right, time to leave the familiar, cool surface behind. We're going deeper. We are now plunging into the Earth's fiery engine. And this next layer, well, it is an absolute giant.
Just look at that number, 2,900 kilometers thick. This is the mantle, and this thing makes up the vast majority of our planet's entire volume.
So what is the mantle? Well, it's kind of weird. It's not totally solid rock, but it's not exactly liquid magma either. It's this strange in-between state, a super thick, semi-molten layer of rock that over millions of years acts like a pot of really, really thick soup boiling in super slow motion. It's constantly churning and flowing. And there's a name for this slow churning, mantle convection. It works like this. Heat rising from the planet's core heats up the rock, making it a little less dense so it slowly rises. Then, when it gets near the crust, it cools down and sinks again. It's basically a giant planet-sized conveyor belt. Okay, so why does this matter? Here's the kicker. This churning isn't just happening in a bubble. It's the actual force that pushes and pulls the massive tectonic plates floating on top of it. And that movement, that's what causes pretty much all of our planet's most dramatic events. We're talking earthquakes, volcanoes, even the creation of huge mountain ranges. In fact, that's how we even know what these deep layers look like. We study the waves from those earthquakes as they travel through the planet. It's like giving the Earth a giant ultrasound to see what's inside. Okay, we've made it through the crust and the enormous mantle. Now it's time for our final stop. We're heading to the most extreme, most mysterious place on the entire planet. Welcome to the core. We are now at the very heart of our planet. And what we find here is basically a giant ball of metal, mostly iron and nickel. And it is unbelievably hot.
Just how hot are we talking? 6,000 degrees Celsius.
To put that in perspective for you, the center of our own planet is as hot as the surface of the sun. Yeah, let that one sink in for a second. But here's where it gets really weird, almost like a paradox. The core is actually made of two parts. You have the outer core, where it's so hot that all that iron and nickel is just a churning liquid. But then you get to the inner core, which is even hotter, and it's completely solid. How is that possible? Well, it all comes down to pressure. The weight of the entire planet is pushing down on it, and that pressure is so immense, it literally squeezes the atoms together and forces them to be solid. Now, this fact, that the outer core is a spinning ball of liquid metal, is honestly one of the most important things about our entire planet, because that motion creates a massive electrical current. It turns the heart of our world into a giant dynamo, a huge engine. And what does that engine do? It generates Earth's magnetic field. Think of it as this invisible force field surrounding our planet, like our own personal bodyguard. It's constantly protecting us, deflecting harmful radiation from the sun, and it even keeps our atmosphere from being blown away into space. Oh, and it's also why your compass points north. Seriously, without it, life on Earth as we know it just wouldn't be possible.
So, we've taken a trip to the center of the Earth and back. We've seen the crust, the mantle, the core. But so what? Why does any of this deep, hidden stuff actually matter to us, living our lives up here on the surface?
Well, let's just put it all together real quick. Each layer has a super important job. The crust, that's our home. The mantle, that's the engine that moves our home around. And the core, that's the protective shield that makes our home livable in the first place. They're all working together as this single, incredible, dynamic system.
So, you see, studying these layers isn't just for science class. It is the key to understanding and maybe even predicting the powerful forces that shape our world. Everything from earthquakes shaking the ground to that invisible shield protecting us from space, it all starts deep inside.
So if there's one thing to take away from all of this, it's this. Our entire existence on this thin, kind of fragile crust is completely dependent on that massive, fiery engine churning away deep beneath our feet. Everything is connected.
We've figured out so much about the layers that literally built our world. But when you stop and think about just how vast and impossible to reach these inner worlds are, it really makes you wonder, doesn't it? What other amazing secrets are still waiting for us, locked away deep below our feet?